how we roll there. Some rock, some win, some 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 win.
Hi, my name is Loris Crow, and we are executing a Showtime. Zig Showtime is a show where members of the Zig community come on stream to share coded ideas with the broader public. Every episode features two speakers who will present and take questions from you, the viewers. Zig Showtime is not just what you're seeing on the live stream, but also the discussions that you can have while watching, and that's why I encourage you to join one of the existing Zig communities that you can find by going to ziglang.org. So, episode 11. Welcome, everybody. Let's see, what do we have for today? I might have something. Well, I guess one thing of interest that happened recently, if you live under a rock and don't read any of the cool social media websites that you should read, of course, we wrote a blog post that kinda got to the front page of Hacker News and Lobsters, whatever. Bunch of these places. I wrote it with Andrew, and it's about the Stage 2 compiler. So if you don't know anything about the Stage 2 compiler, what the plan is, go check it out. If you know, well, now other people also know. So I guess it will be easier for you to explain to people what's happening with Zig. And also the blog post features doodles by Protti, so I guess that's another reason to want to check it out. On top of that, what else do I want to say? Oh yeah, the newsletter. If you don't know about the newsletter, check out the newsletter. I am not going to even try to introduce the talks on Twitter anymore. It's too tedious and too much information gets lost. I'm just gonna put a better, more interesting description in the newsletter. And so if you want to know, like if you have the question of, okay, what's gonna be presented next Showtime, go read the newsletter. You don't even have to give your email. There's the online archive, just read, there's the button, read past issues, just click that, RSS, whatever you want. So you can pick your poison. So let's move into the first talk then. Today we have Felix with us. So let me transition. And let's start with the introduction. So 1 second, let's see if Windows allows me to do what I want. Yes, okay. So Felix is back with another talk. Last time it was a home computer, and this time is a small programming language for video games. If I understood correctly, he wants to write a coding game because when he needs a break from programming at work, he likes to go home and program some more. And honestly, I really hope he is going to be successful with his endeavors so that one day he'll be rich enough to really dedicate himself to his passion, programming. The talk is LoLa. When you don't trust the coder, you may be a game creator. So Felix, the stream is yours.
Hey, yeah, as Laura said, today I'm going to talk about LoLa, a programming language. It's quite small. It has, I think, 12 keywords. It's not your biggest language. It's maybe not the easiest language as well, but yeah, it's my own language. And the question is, why the heck would you create another programming language? There are so many out there. And yeah, I wanted to build a coding game. And there are many games out there, like Else Outbreak was the original inspiration, but also all the tech-like games like Shen.io or Exapunks are based on coding. And I really love these games. So I thought, let's do one yourself. And I checked out existing scripting languages like Lua or Python. And well, none of them really had my requirements fulfilled. So the question is, what requirements do you have to not be satisfied with the existing languages? Well, for one, the language should be simple to learn. So the players of the games are most likely not being programmers. So not only they have to learn a new game, so they also have to learn a new programming language. This is maybe the least hard requirement. Like Lua is really an easy scripting language, Python as well. So we could live with that. Another thing was scripts must have an execution quota. So if I'm going to like run a process in a classic scripting language, it will run until the language returns. So if the player makes a mistake, like programming in an endless loop, we're having the problem, well, the script does not return ever. How do we solve this? And another thing is, we're building a game. So the player will press save, and also the scripting runtime should be snapshotted and serialized, so we can later restore it to a point where the player left off, which I think none of the programming languages I looked at had this feature. And the last one is it's a sandboxing requirement, which can be solved with a lot of programming languages. I think Lua doesn't guarantee sandbox safety. They go for more performance instead. And WebAssembly provides us with this, but we need a compiler as well for this. So yeah, these were the requirements. And I thought, hey, let's do your own programming language. You wanted to learn it anyways, so here we go. As previously said, my inspirations were Else Heartbreak with the programming language Sprack. It features interconnected systems in the game, so there are hundreds of computers running in parallel, executing scripts which you can modify. One example is your credit card is a computer you can program, which connects to the bank computer. And at some point in the game, you have infinite money because your credit card is always possible to use. It will accept any transfer of money. You will always have the same bank account, because bank balance, because hey, I made it that way. The other games are like the Zectronics games. Here, TIS 100, Shenzhen.io. Those games have this really nice property that you're given a goal, not like a way to reach it. So your classic computer game is you have to beat this way we made for you to reach your goal. And the Zectronics games are like, yeah, this is the goal, get there somehow, no matter how. And yeah, I both liked these games and I took inspiration from them. So yeah, enough introduction. Let's go to the first programming language example. Hello world. Well, looks like JavaScript to me. It's also a Java syntax highlighter. So getting more in depth with another better example maybe is this. We still have arrays like in JavaScript. We have a for each loop similar to JavaScript or C#. We have variable declarations. We have if. Yeah, it's nothing surprising here. The language is simple. The language was modeled after C# or JavaScript. And yeah. So how does the language work in practice? I'm going to do a little live demo now. Thanks to Zig, we can compile nearly all programs to WebAssembly and build our nice little playgrounds on the web. So yeah, this is my playground. You can choose an example on the right. You have validate, which compiles the program and checks if there are syntax errors, and you can press run and execute the hello world. Yeah, it's nothing special. We can do also by, and I made a typo, and we get here, there's invalid byte sequence. The exclamation mark is not a valid token. So yeah, you can play around here. You can find this playground on my website. Where is it? It's lola.random-projects.net, There's the documentation online. There are infos about the community. There's my currently failing builds. The GitHub repo is linked. So yeah, you can find all information you want on this website. Another example is what I was talking about earlier is the quantized execution. So I have an endless loop, and I can press run, and the code will run. And I can press stop anytime without multi-threading or exceptions or whatever, and I can just stop the execution again. This is a really useful property, so you can just run your script for like 1,000 instructions or slices, and the script will return, and you can continue later. And here is a more complex example where I can talk about semantics of the language. I've implemented a wonderful function called bubble sort, which most of you should know already how to implement it. So when you run it, it will sort a list of numbers, and it will sort a list of strings. And the language has no reference semantics. So we have to put an array input into the function, and the function will return a new array. So this array we're passing in is getting copied, not referenced. So yeah, we're creating a copy of the array, we're determining the length, we're executing bubble sort, and we're returning the arrow again. Nothing special, it's all plain and simple. The function, the language also has stack traces and panics. So when we run this code, it will panic at the function boom here. And we can see if we call within, it will call deeply, it will call nested, and nested will call boom. This will fail, and we get a nice stack trace. So debugging tools are there as well. And one feature of the language, which is unusual for scripting languages without static typing, is that the language actually has a type checker. So there is no coercion between types, so I'm assigning a string here, and I'm adding 10, which is not a string, so it will type error at runtime. And the nice thing is I can press validate here, and it will tell me in line 2, I cannot add the 10 to string because string is a string variable, which is here, and 10 is a number, and those are not compatible at this point. We can change this, though, by using an assignment of a number, which will now allow in the type checker that string might be a number, so this code might be okay. It's very conservative and will only give you errors or warnings when a type error must happen at runtime, not if it might happen. Yeah. Okay. So yeah, the language design was a recognizable syntax. As you've seen, it's really C-like or C#-like. There are no reference semantics, as told. There are also no objects like the hash maps we see in Lua or JavaScript or Python. The language scope is quite small, and I don't think it needs these objects. It would be possible to implement them. I'm open for a proposal as well, so they might come. Yeah. And it's also shown that the compiler can detect guaranteed type mismatches and print a warning. So yeah, the simple to learn requirement is met, in my opinion. It's an easy language, it's documented, it has examples with everything we need to learn the new language anew. So for the next point, we need to have this quota to limit execution. And at first, I implemented the language the language runtime as an AST interpreter. And I noticed that as soon as I'm in a loop, I cannot break out of the loop without returning in again later. So this wasn't the best idea. So I went the way all script languages work. I've gone with a bytecode. And the virtual machine, you can just say, hey, run up to 20,000 bytecode instructions and return back. And you can resume that state later at any point. And as it's meant for game scripting, we also have like long-running functions. Like we have a function which is the simplest is sleep for 10 seconds. We don't want our game to like freeze for 10 seconds when a script calls these. So we have asynchronous functions which immediately yield control back to the host of the script. And you can return later to check if the asynchronous function already completed or if you have to wait more. So here's an example of the bytecode for a very simple program. It's a stack machine. So we have push instructions, we have store instructions with global variables, we have call instructions. It's the usual thing. All the instructions are documented and should be self-explanatory if you've read the documentation, I hope. So yeah, next point is also successfully fulfilled. We can execute only pieces of the code and pause at any time. This wasn't also the hardest part in the language, but the next one will be its serialization. Serializing a script language at any time in the execution wasn't trivial. I had to think a lot about how to implement it, how you can recover any state later. And I have to admit, it's not fully implemented yet. Asynchronous functions calls cannot be serialized at the moment, but I have a plan for this and I just haven't had the time to implement it. Yeah, the runtime is fully serializable. You can pause the execution at any time, send the state over the network to another computer and resume execution there. The language, as said, has no reference types, which makes serialization really easy. You just dump all your values into the stream, and you can restore them later without having to resolve loops in the type structure. But it's only for the value serialization. The serialization of the whole state of the virtual machine wasn't that easy. Oh, also here, a live demo. I have prepared a small script, which is divided in 3 parts. We have one part that has an allocator and runs some code. So compiles some code, runs it, serializes it into this buffer. Then we print a nice divider to see where our upper part and lower part are running. And we deserialize that buffer again. So the only interface between this code and this code is this buffer. So a flat buffer without any addresses in it or something. So just serialized data. And the code we're executing is a simple for loop from 1 to 100, printing each round we're in. And when we run this, we can see we successfully printed up to 100 elements, starting at 1. And we can see in the middle of it, we're suspending at offset 29, that's the bytecode offset, which is line 1. So we're in the for loop implementation above here. It took 1006 bytes to serialize the whole state. And we're restoring those bytes again, resuming at the same position, and just let the code continue. I think this is one of the most unique properties of LoLa, that you can serialize at any point and you're safe to resume the code later. Yeah, next part of the requirement list is also fulfilled. Wonderful, one left. And this is where Zig really helped me in implementing, because first I can use an allocator with a memory quota. So let's say this allocator is allowed to allocate up to 1 GB of RAM, and if it goes above, it will just out of memory and the execution will fail. So I can safely check if scripts are using too much memory or not. I can catch endless loops by just using the quota, so the script will just return after 20,000 instructions, and the endless loop will not halt my program. This is also nice. When something bad happens in the script, I'm getting a LoLa panic. So the script will just error out and say, hey, I'm broken. Please recover my state and resume me later or whatever. And LoLa panics are implemented as Zig errors that bubble up to the host, which is convenient. The same for host functions. So when a host function errors, it will also just bubble up the error through the virtual machine to the calling host or to the embedding host, and we can safely see that our script crashed, so no runtime crashes at all, which are not recoverable as for the host. So our games will not crash in any cases when the script goes wild. And also here a little live demo, which isn't that as exciting. I've looked up some implementations of in-browser scripting languages. One is Fangario. It's Lua in the browser, and when I'm typing a simple endless loop, which does nothing, I can make it big, and I press enter, the site is frozen. I cannot interact with it anymore. It's broken. That's not the state that we want. It's inconvenience for the user. It might use up battery life. It's not good. The same happens for JavaScript. I have no idea why this returns, but the site is now also in a kind of inoperable state. So you can see it doesn't work anymore. This JavaScript is frozen. We cannot resume. We cannot use it anymore. And let's hope this will close. No. When we do the same thing in LoLa, it will just work. We can use the site, and we can press stop at any time, resume the code, putting a thing here in, print, loop, whatever, and let it run, and the site will still work. We have no problems in using it. So yeah. Last requirement is fulfilled. We have now a language that is easy to learn, which is executable in quantized pieces, so our programs will never freeze. We can serialize every program running at any time, and the user cannot break our host, which is also a nice property. Yeah. And for those who want to use the language, I'm now going to explain a bit how the API works. This is a basic program showing us how to use LoLa. Most languages have these 20 lines of code as a single line. So there's the Lua do-file or do-string API, which compiles and executes a piece of code. But LoLa is about having control over your execution. So I've split that up into host API as well. The first part above here is a call to the compiler, which requires an allocator to create our compile unit, which has a set of diagnostic messages. These are the messages we're seeing. Not here. We're seeing down. We're seeing here. These are diagnostic messages. We have errors and warnings. If we successfully compiled our code, which is this, we need another thing to get running, which is an object pool. LoLa itself has objects in the language, which are opaque to the user. So having an object is, I think I have enabled it, I'm not sure. No, I have not enabled it in the runtime of the website. So you can create objects, which are opaque pointers, which have methods you can call. So this is everything you can do with an object. You can compare objects and you can call methods on them. The point is objects are garbage collected. So I can do list2 and list, and this is actually a reference. So this is a reference to host objects, and this needs garbage collection. And for this garbage collection, we need an object pool. The object pool provides serialization for the objects. It provides deserialization. It provides management, memory management. So it allocates or deallocates the objects. With a compile unit and an object pool, we can initialize an environment. The environment will contain all global variables and is like your process of execution. So in classic OS, this would be the process, and we can install functions into the process. Here I'm installing the whole standard library, which contains stuff like substring, length of an array, and so on. And to actually run code, we need to initialize a virtual machine. This takes an environment and will run the code in the environment. So a virtual machine in LoLa is a thread in classic operating systems. And we can now execute the virtual machine for 150 instructions. If we're not interested in having quantized execution, we can just pass null here and get infinite execution until the script either errors, is completed, or will suspend because of an async function. And we're getting a result which tells us what happens and why the virtual machine returned. Yeah, this is just for people that watch the slides later. Explains the stuff I just talked about. Yeah, so maybe LoLa can be your next best programming language. Maybe you're building games with it, maybe not. You have total control over the execution and the environment. You can hack into any piece of the language and change stuff of the execution. Everything is serializable, which is also a nice property. Yeah, so thank you. This is it.
Thank you very much, Felix. Wow. So let's move into the Q&A. Let's give it a few. Let's give a moment for the chat to come up with questions. And there's Matt clapping in chat, by the way. So we have actually one question already that Sobson had earlier, and I think it's a very appropriate question. So it's about the logo, the character, right? The mascot. Is she your waifu?
Nah, it's like a personification of the language itself, but no, it's not my waifu.
Okay. I am forced to report all questions that the audience is asking. So, so that was nice. I think that you made a very, very strong case for having having those features that seem like after your presentation they seem fundamental. I don't see how anybody could do without those features. It also, it kind of made me wonder, there are some games like that have Lua scripting, right? I'm thinking about Skyrim. I might be wrong. It might not be Lua. I haven't done it myself, but there are plenty of games that, for example, have Lua scripting, and mods use Lua scripts to do stuff, and mods also have weird interactions with one another, crash the game, and everything else. I think that's an interesting argument for maybe not every game. Maybe some games need the extra performance that Lua provides, as you said earlier. But maybe some of those games, even if it's not just for the end user, like for the player to program with, even for modding could be interesting. What do you think about this?
Yes, actually, this is true. And I think the language is also quite well suited for the general in-game scripting. So like programming how your NPCs should work or talk and creating, the top level game logic. The language itself is also suitable to build stuff like the RPG Maker series programs,
Right.
where you have also these super asynchronous scripts where a function call could take like months when the player is just sleeping in front of their PC. And as you mentioned, Lua, there is actually a way in Lua to create like this quantized execution, but it's horribly slow because you have to check into the debugger and like count in Lua every time when an instruction was executed, which is not very performant. But it's the only way to get, to my knowledge, to get this paused execution thingy.
Mm-hmm. Let me think. Another question. Well, let's see what the chat has. So there's a question from Nipsey. What was the biggest hurdle to overcome during the implementation of LoLa?
I think the biggest hurdle was actually the whole serialization thing, where I think I needed 2 weeks to figure it out how to do it properly, and even then the implementation was not straightforward.
Mm-hmm. Another question. What garbage collection method does the LoLa runtime have use?
It's a manual mark and sweep algorithm. You have to call some methods on the object pool, which is shared among all environments and virtual machines. So you can even have across objects in multiple virtual environments at the same time without interfering each other. And it's basically a mark and sweep garbage collector, which should be called sometimes.
Mm-hmm.
Yeah.
Okay, another question from a rude dev. Can you talk about parsing a bit? He also continues. I've never written a parser, and I'm curious about what type you chose and why.
Oh yeah. I've actually rewritten the LoLa 3 times by now. It's my third attempt. First was in C# with a Bison variant, so a parser generator. The same with the next generation, which was the C++ implementation, which also had the parser generated parsing. And the Zig version now uses recursive descent parser, completely self-written. And I can show some of the code.
Sure. Let me bring up the view.
Yeah.
Yep.
Let's close the terminal. The parser for the whole language is 1,700 lines of code, which with a lot of testing. And if I'm talking a lot, I'm talking a lot. So without tests, the parser is 800 lines of code. The parser is recoverable. So if I'm doing stuff wrong, I can open a block and I can like forget to call a function, whatever, and do the same thing here. And if I'm validating, can actually detect syntax errors here and there, so in both places. Parser is recursive descent, which is basically a lot of those except functions. And the top level is, I think, except statement. this is the top level function for statements, which this is a statement or an assignment is a statement. And I have a parser state, which I can restore later. So when anything errors in accept statement, I can jump back to the place in the parsing before I changed anything in here. And I'm checking out here. It's basically switches and those accept functions, which check for token types and return the appropriate stuff in the AST. And the parser itself outputs a syntax tree, which is a list of statements on the top level. So if I'm doing this, this will be a node in the root script. And if I'm doing a function, this will create an entry in the functions table. And functions are just statement lists with a parameter list. And the AST is implemented as two tagged unions, one for the statements and one for the expressions. Yeah. I hope that answered your question. If not, feel free to come back later at me and just ask me.
Awesome. Yeah, I think you were very thorough with your answer. Let's see. Oh, I have another question. Do you have any like CABI bindings? Do you plan to write some? Any problem? Because I expect like game developers, like if you want to attract game developers, they will probably have their C++ game already written, and maybe they will think of, let's see how hard is it to adopt your language. So what's the state?
Right now, I only have a GitHub issue which says, please design a CABI compatible interface. But yes, I'm planning to implement this and provide a CABI or C API for the language itself, because as you've said, there are a lot of C or C++ programmers which would also benefit from having this language available.
Yeah, I'm also thinking that once you have CABI, you also get stuff like Unity, right? Because they will be able to use your stuff from C#.
Yeah, exactly. So you can import the binding in C# and use it from there, or you can use it on Android or whatever platform.
Right. I would not want to code on Android, but yeah, I get your point. It's also for the game mechanics itself.
Yeah.
Okay, that's actually really, really, really awesome. Thank you very much, Felix. I don't think there are other questions. Let me take a peek at other places, but I think we should be actually, no, let me double check here. I think we should be good. Yes. Is there anything that you want to say before we move forward?
No, just thank you for having me, and I'm looking forward for my next talk.
Oh yeah, next talk is gonna be a t-shirt, right? Yeah.
Yeah.
It's a shame that Benjamin, he was so close, and then I don't know what happened. That guy. Anyway, thank you very much, Felix. So let's move to the break. 10-minute break. But don't go away. Come back, or rather, come back, because we are going to talk about Zig errors, panic, and unreachable. Which should you use? When? Why? How? So yeah, see you later. Hey, we're back. I'm giving a few seconds for the people that have tabbed away to tab back on the right Twitch tab. Stop watching Ninja. Oh no, Surad, you triggered a blue screen, but blue screens are disabled during showtime. Sorry. I refund your points though. Don't worry. Scammed. No, I can refund those points. And okay, so error, panic, or unreachable. Let's find out. Let's find out. So, closing the, yeah. Okay, error, panic, or unreachable. So, this is a presentation. This talk is about deciding which to use in different situations. And the idea is that you started programming in Zig. You now know what these things are. You've seen them, so you have a general idea what they are. I will also introduce them again, but the idea is that you kind of know what a panic is, you know what an error is. You also have seen unreachable in a bunch of places, but at one point, like you're writing your own library or even just a function inside your program, a like function like nested inside a little bit, so not top level in the main, and you wonder, oh, this weird condition, should this be an error? Should I panic? Should I write unreachable? And I think there are these are questions that everybody stumbles upon sooner or later. It happened to me for sure. So let me try to give you an overview of what these things are. As with my last talk and also on my talks in the near future, I'm not going to go too much into details on one specific topic. I just want to give you an overview and a general understanding, like guide you towards the right direction. But after that, it's your job to go read the documentation and learn more, or go on Discord, IRC, Reddit, and ask questions there if you are still uncertain. So, have you ever written a program that handled all errors correctly? I think I should really give chat a moment to answer. Like, raise your hand if you have. I don't think I have, honestly. I think I'm not joking. I think until today, I think a pretty good job, but I never really got to the point where you say I handled everything. And it's important. Proti says yes. Hello world. Well, we'll see. We'll see, my man. We'll see. But that's for the end of the presentation. So this is seriously interesting. If you if you program professionally, chances are that you never do that correctly. But it is important. We realize it every day. Software is broken all the time. And if you just saw the presentation from Felix, there are serious reasons for having your programs be stable and not explode when something bad happens. So that said, while we know what the reality is, for this presentation, let's just make a courteous assumption that yes, we do have the time of thinking about not just the happy path in our program, but also to handle all the weird things that can happen, all the weird situation states that the program can end up in. Well, that said, handling errors, to be fair, such an easy problem, right? I mean, this is going to be like a 20-30 minute talk. I'm sure we're going to cover everything from start to finish, right? No. No. It's not easy. Handling errors is complicated. As I said in the introduction, I am going to cover different means, but I won't go into the details. So, and also, if you've probably seen other talks about error handling. There is so much depth in there. Whether you're building a program, whether you're building a library, depending on who your end user is, so it's a serious problem. Anyway, what do we have in Zig, or more precisely, what am I going to cover today? Well, today I'm going to cover briefly Zig errors, panic, unreachable. These are the ones in the title, but it's not just those. There's also compile error. There's also errors as values, and there's probably more. There's also other things that maybe should be in this presentation, maybe should not. I wasn't sure. So this is what I'm going to cover today. But an example could be optionals. Optionals are in a sense connected to handling errors, but also they are somewhat, I think, easier to use than the other things that I'm gonna mention today. So let's get started. Compile error. What's compile error? Compile error is a programming error that you can discover at comp time. Compile error, the way the statement, the built-in works, it relies on Zig's lazy evaluation. So generally speaking, you put a compile error inside an if statement. So your if statement has a condition that can be resolved at comp time, and that's a failure condition. So if the failure condition happens, the if gets simplified and just the compile error remains, and that's gonna cause the compilation to fail. Normally, you want to compile error takes an argument and a string argument, and you want to put in there a useful error message so that the user, which in that case is a programmer, can fix their code. As I said, it's a programming error, so who is going to read those errors is another programmer, not an end user. Let me give you an example. Let's say that you have this function called insensitive equal, like it's a case insensitive equal, and for some reason you decide that one of the two strings should always be uppercase because it simplifies the comparison algorithm. It actually does. Not sure if it's worth making a function for it for normal cases, but your function then relies on the first argument being compile time known and written uppercase. But some people might misuse your function, right? So how do you do it? How do you enforce that constraint? Well, inside the function, you can write in line 4, which is gonna check that every single letter is uppercase, and if not, or actually, let me flip it around. If it finds a lowercase letter, it prints it just compile errors with a message. So if you write this in your code, and somebody writes a main function, so writes a program where they use your insensitive equal function, but they misuse it, right? The first argument should be all uppercase. When they try to compile, they get a compile error, and the compile error tells them that upper must be all uppercase. And you even get a nice error trace that even points to where they made the mistake, which in this case it's line 24, but because that's from my real example, it would be line 1 if I actually ran the program from the other slide. Next, panic. So let me see if there's anything else that I should conclude with. No, not really. I mean, compile errors are so nice. I guess in C++ people use asserts for this and then get all surprised when people make up like a release and with optimizations and asserts disappear and oops, now everything is broken. In Zig it doesn't happen because there's compile errors are precisely checks for the compile step. Panic. What's panic? Panic is an unrecoverable error condition that you discover at runtime. You should not have panics inside your libraries, generally speaking. And in practice, most of the time, they are the equivalent of to-do error handling. So is what people tend to abuse a little bit. How do they look in practice? Let's say that you have this function that should do something with a line read from standard input, something like this, I don't know. And if the buffer length is 0, so if it didn't capture anything, then whatever else you're trying to do doesn't make sense. So you check for the error condition, then boom, panic error. And this is what you will find out in the wild, probably, in all languages, not just Zig. Panic error to do error handling, right? That's the reality. But there are sometimes conditions that are really unrecoverable, especially when your application, when you are at the top level, right? You are inside your main. In there, sometimes there are errors that you don't have a good strategy to recover from. So sometimes, genuinely, the right choice is to just just crash. And when it comes to systems programming, maybe that's not often the case, but I made in the newsletter, I put this as a joke. But when you're writing like distributed services, it's a reasonable choice sometimes to just crash and let whatever else is outside, like the Kubernetes or whatever is in fashion now, have that thing spin up another process. Because sometimes you encounter error conditions where it's completely out of scope from your application to try to address them. So for example, let me give you one example about web stuff. You're writing a web service and you cannot connect to the database. What do? There's nothing you can do really, right? It's not your program's role to, I don't know, try to restart the database. Normally, that's not how you would want to do things. So at that point, you just panic. That's reasonable. Let's talk about now Zig errors. Zig errors are recoverable error conditions that you discover at runtime. They are error codes only, not messages. So they are basically, think of them as enums. You can access the error name, so you don't worry, you don't have to learn which number corresponds to which error, because they're defined inside a header file somewhere as macros, but they don't carry payload. So if an error of one type happens, there are no other context information that error codes will that Zig errors will carry with them. They are implemented as a union. They are, if you look at the documentation, you can find information about the error union, and they usually errors attach themselves to the return value of a function. So they don't behave like exceptions. They are normal values, and Zig has a built-in syntax to have you create a error union with your expected return value. And then we'll see the code example later. So there are a lot of language tools to manage Zig errors, like a lot. I'm not going to cover them today. You can unpack errors in many different ways. There are many different keywords that help you manage them. I'm going to just show you a couple. And again, the point is not to give you a full introduction to Zig errors. I think Zig errors by themselves would probably deserve a couple of talks, one for a general introduction, one for maybe advanced patterns and funny tricks that you can use. So I'm not even going to attempt that. But just to show you an example, you have, I don't know, this function that it's parsing from a buffer a number. So we have this buffer is basically a string. So we have this string, we try to parse a number into a usize number base 10, and we return the next number. Not a particularly great function, but just as an example. As you can see here, parsing the number can fail. Makes total sense, right? We don't know what string is in here. And this is why we have the try keyword. The try keyword will take the result, the value that resulted from calling this function. Try expects the return value to be a error union. And if it finds that we are in the case where it's an error and it's not the correct return value, it will automatically return that error. The exclamation point before the usize here, this is the return value of our function, right? The exclamation point says, well, in success case, we want to return a usize, but in a failure case, we're going to return an error. So that's the exclamation point. Again, there's a lot more to say about this exclamation point and try and everything else, but I'm not going to cover this today. But you can see how generally speaking the flow would be, right? If you try to call this and there's like 100 in the buffer, then it will succeed and it will return 101. But if you call it and you pass it banana, and what will happen is that if your main also calls that function with try and also the main has exclamation point void as return value, Zig will print the error, invalid character, because it finds a B, not a good number, not a good digit. And then it will show you the error the error trace. So it will show you that the errors came from here. There's also the stuff that I omitted to have safe space in the slide, and it will bubble up to where it actually we had a try. So from hello.zig, this is the code from that I ran this example from. So it will show you also what the error did. Next, I said that these are recoverable errors, right? So recoverable errors means that you can also do something with them. You're not supposed to just throw them up with try all the time. Sometimes you get to a point where you can actually do something about them. And another language feature that you have is, for example, catch, which is kind of like try in the sense that try does something when you are in an error case. Catch, likewise, captures the error if the return value from calling this function ends up being the error case of the union. And then we switch over this error, and we can switch over it, and we have two errors that are possible from parseInt. Again, I didn't show this feature, but also you know which errors come from functions. This is something that the Zig compiler will tell you. Except in particular cases, normally you will know precisely what all the possible failures are. And in the case of parseInt, these are actually the only two possible failures. It either overflows because it turns out that this number is not, like, usize is not big enough to hold that number, or returns invalid character, which was the case from banana before. And here, if you capture them, then you can think of what to do in that regard, what your recovery strategy is. So with panic, you cannot really do that. So I made a distinction here between recoverable errors versus unrecoverable errors. Which is which? The answer is you decide. There is no fixed rule that says this is a recoverable error, this is an unrecoverable error. It's your choice to decide. Well, if you are writing the application, if you are the final programmer, you know what your domain is, you know in which context your application will be run, and then you know what your application is supposed to manage and what the application is not responsible for. So, for example, if the database is dead and you cannot connect to it, maybe you can retry a couple of times, but after a while, there's nothing else you can do. Maybe you can retry indefinitely, but you cannot do much more than that. While for other error conditions, these are errors, but in a sense, they are business as usual, right? They are error conditions, but they're expected. So for example, if you're writing a command line interface, you should expect your users to write commands that don't exist, have typos, make a mess. These are errors. But they, as I said, they are very much errors that are expected, and it's no discussion that your applications should handle them. So you should not panic if your user types a command that doesn't exist. One last thing that I would say in that regard is that there's also a difference if you are, as I was saying earlier, if you are the top level programmer, if you're the final programmer, and then after you, there's going to be just users. That's one thing. But if you are a library author, if your application ends up being used by other programs, by other programmers, then it's a bit different, right? If you're writing a Zig library, you most probably do not want to panic. Although that said, when you not panicking means that you need to, your API needs to account for all these error conditions. And I can imagine maybe some situations where your library, where you're writing a library where you don't expect the other programmer to really be able to handle everything. I don't have a good example right off the top of my head, but the point is, these are the decisions that you have to make when you're writing code. And generally speaking, in libraries, you don't want to panic. You want to give an opportunity to your caller to handle any possible error. Now, let's go talk about unreachable. Unreachable is a bit peculiar, and it's used to express when a situation is impossible, when you cannot express that through other means. So as an example, we use types a lot to constrain the space of possible states as to avoid invalid states. That's probably the best way of doing that. Like the best way of avoiding invalid state is not to have it representable at all in the system. So an example is that if you have a function that doesn't work with negative numbers, you have it accept a unsigned number, and that's a good way of avoiding it. But you cannot do that always all the time. So this is where unreachable comes into help with that. Now, unreachable means that you are providing from the outside a guarantee to the compiler and also to other people that are reading the code, actually. So other people that will write code, use your library, etc. When you are debugging, when you are doing a debug build or a release safe build, undefined behavior will be safety checked. So if that situation that you just said it's impossible actually happens, Zig will panic. But if you are compiling in release safe mode, then you end up having undefined behavior, which is a problem. It's a very sharp tool. So unreachable is a very sharp tool. You should use it with care. And let me show you a practical example of where you might want to use it. So this is similar to the previous example where we were parsing a number, right? But this time there's a small difference. Now buffer, it's not a slice anymore. So we know it's an array now. It's an array with with a length of 3. So we try to parse 3 digits inside a U32 base 10. And we know that it's impossible for 3 digits base 10 to overflow a U32 number. So we can say, so while we are handling all the errors, this overflow error, we know it cannot happen. So if we didn't have unreachable in another language, maybe here we would say, we would leave a comment, we would do nothing, and maybe we would leave a comment like, this should not happen. Or maybe we leave a panic or something. We do something that it kind of feels weird, right? Because you know this cannot happen. But in Zig, you can have unreachable. Now, this unreachable, it's nice because it, first of all, it will be checked in debug and release builds. So if you have a test and you, which is a reasonable expectation, you should test your code, right? But if you have a test, how can I say? If somebody changes this number and this ends up happening, so maybe they change this 3 to 300 or 3000, I don't know, and they trigger this case, the test will fail, and you will see that happen in your tests. But otherwise, as long as this stays like this will allow the compiler to optimize this code in a way that it would not be otherwise be possible, because it doesn't, the compiler doesn't do this kind of reasoning. Actually, I don't know for sure, to be honest, but most probably doesn't do this kind of reasoning. And in any case, this is just an example. There are always cases where you know something that the compiler doesn't know or cannot even know. So this is unreachable. Now, why do you want unreachable? I mentioned like that the compiler can optimize stuff, but let me try to answer a few questions and dive into that a little bit more. Why is unreachable at all? And the answer is, I would say, mainly performance. The second reason is that, as I said, there are some situations where you know a situation is impossible, and maybe you have to make the type system match, and it's so annoying because there is no good answer, or like you don't have, it feels really bad. I don't know if it happened to somebody, or I think it happened to me multiple times in the past. So I would assume this is something that happens fairly frequently, but it really helps you work with the type system in a very nice way. Because unreachable is one of those types where Zig knows that if you end up in there, well, that you don't end up in there, actually. And so it won't annoy you with the type system. Is undefined behavior that bad? So what happens if you get it wrong? You should not get unreachable wrong. If you get it wrong, test your stuff. Please write a test for your unreachable stuff to ensure that it actually really is unreachable, so that your test can fail. But what happens if you end up with undefined behavior and runtime? Is it that bad? Yes, it's super bad. Undefined behavior means that people keep repeating anything can happen. The practical answer, I guess, is your stuff will break and misbehave in weird ways. And the reason for that is not necessarily because the computer is evil and it's punishing you for getting things wrong. maybe. But the other reason is that, well, Felix earlier mentioned games like TIS-100, TIS-100, and Shenzhen IO. Like, I remember playing Shenzhen IO, and I forgot to put a screenshot of that. But in Shenzhen IO, it's this game where you are basically an electronic engineer, an electric engineer, and you're building circuits and programming stuff, and you have to manage the budget of what you're building. So if you add more chips in your stuff, they're going to be more expensive and you lose points. And also you have constraints in terms of space. And then after you build your stuff is supposed to respect a set of specifications. The game tests your circuits. So it has a testing routine where it tries to utilize it, and it has to perform as expected, right, to specification. I remember that there was one level where you had to build a controller, like a gamepad. And I remember trying to build a super cheap, crappy gamepad where if you press too many buttons at once, it would not work anymore. So you could press 1 or 2 buttons. I don't remember precisely the limit, but like it would work for simple cases. But the moment you tried to use it seriously, it would misbehave in weird ways. And why was that? Because I was trying to be cheap with the number of lines running through the thing, and I wanted to save a couple capacitors or something. So, again, the spec that I was given, so I ran the test, and I think I passed that level, and because the spec that I was given did not account for that possibility. So, I'm mentioning this because undefined behavior exists because your machine mimics the semantics that you are trying to give it to it. So when you're doing a sum, the machine is mimicking that sum through other things that happen in the circuits, and that means that the machine is not precisely doing what you're telling it all the time. Then undefined behavior basically means that according to the spec, you're trying to do something that you're not supposed to do, and so the machine will not only misbehave, but it will misbehave in weird ways, in ways that don't map correctly to any of the semantics. So this is the undefined part, or the maybe confusing part, the reason why people say the machine will be able to do anything. It won't really be able to do anything, but it will start misbehaving in ways that are dictated by reasons that don't map to the specification even remotely. So, long story short, undefined behavior is bad. So why do you want to have undefined behavior? Why is it like not avoiding undefined behavior in all possible cases? Well, if you are building, again, if you're doing a debug or a release safe build, you will not have undefined behavior. It will catch it, I think most cases. I think there is a plan for everything, but I think there are a few cases where you can trigger it anyway, like writing the wrong memory. But anyway, these things are being addressed. But if you're building a release fast mode, all the safety checks will be removed. Everything will be simplified, and that is what has your application run much faster. It's a performance optimization, and the performance gains are good enough that it's worth having this stuff. So that said, another thing that maybe sometimes I've seen programmers get themselves lost a little bit into is, well, but I'm saying that this is unreachable, but what if something weird happens, and even though this is never gonna overflow, but somehow a bit gets flipped in RAM and another program messes up with the memory of my program, and we actually end up with an overflow. And if I leave unreachable, then my application will be broken. And the answer is no. These type of failure scenarios, you cannot account for them in programming. If your machine is broken, then nothing is gonna matter anymore. Or if something else incurred in undefined behavior, then everything else is invalidated. There's a interesting talk about this that unfortunately I could not find a link for, but if I do find a link, I'll add it to the video description on YouTube, which was about weird machines. And the idea was that once your machine enters undefined behavior town, then everything is possible, and there is really no way of going back from undefined behavior, at least through normal means, and with the architectures that we have today and in our homes. So, long story short, unreachable is, I mentioned unreachable because it's in the ballpark of errors, but it's for optimizations and it's not for errors. Use it with caution. The compiler, with unreachable specifically, the compiler will always have your back in debug and release safe builds. And when you have code that needs to go really, really fast, unreachable will be a very useful tool. But again, you have to get it right. If you don't get it right, then stuff like this happens. Honestly, I don't know if this is because of undefined behavior. I have no idea. It's just a funny screenshot. Yeah, there are consequences if you get it wrong. Okay, final topic, I believe, errors of values. This is in some ways a milder topic, I guess, but I think it's one of the most useful because here's the problem. Zig errors don't carry a payload, right? Exceptions in other languages do carry a payload. Zig doesn't, because Zig errors, you want them to be small, right? You want them to occupy, you don't want to have a big overhead for moving around those errors. You want them to be useful, to be better, I would say, than like error codes from C. But you would have a lot of overhead just to ferry around strings when maybe somebody doesn't need them. But sometimes you do need errors. You do need payloads like strings, something that gives you more context of what the hell is going on. So in that case, you should implement them yourself. And you can just do a tagged union, and you have your type, you make a tagged union with your error type, and the error type can be whatever you want, and you can tailor that to your application domain. If you want to have your own custom errors and you don't need any payload, consider using Zig errors. So I didn't show you how to make your own errors, but actually super simple. You just type error dot blah blah, and whatever you write, like you don't have to declare them beforehand. You just type error dot whatever it is, and Zig will do a lot of that work for you. So they are really, really nice to use. Let me give you an example then of using errors as values. So this is from my Redis client library. It's on GitHub, Christoph-IT/Zig-OK-Redis. And there are the library basically is trying to give you a nice, easy to use interface and help you with a lot of stuff and give you flexibility. But at the same time, I wanted to make sure that the library did not have any foot gun in it. So there should be no gotchas, no behavior where, oh man, the library really screwed me in that situation. I didn't know this. This is something that you should not do with the library. I wanted to avoid all of that. So when you try to send a command, so get key, this is a Redis command. If you don't know much about Redis, it's a key value store, and you can send commands like set key, get key, and a bunch more. Here I'm trying to get a key, and I'm also requesting that the result value is decoded into a I64. So I'm expecting this to return a number. There's a try keyword, because whenever you call, so I'm not showing you everything or how to instantiate it and everything else. I'm just showing you just the core part of the API that deals with errors. So the try keyword is here because there may be a lot of errors that can happen in here. You're trying to do network I/O, right? So there could be broken pipe. There could be a bunch of networking related errors. But on top of that, there can be other errors related to types, and there can be other errors related to Redis errors. So this command can return you a Redis error. Maybe you don't have permission to access the key. So here, the return value, the expected return value, I64, doesn't account for representing errors. So what I did in this case, using a bit of metaprogramming, is that when you encounter a Redis error, This will return you in the case, so like you get an error that says that you don't have permission. Here, this will return a Zig error called got error reply. It has a bit of a wonky name, but it's on purpose because it's not something you should abuse. So in this case, I will convey an error condition sent by the server through a Zig error. But at the same time, I also provided a generic type which takes in any type that you want. So it could take in I64, for example, or it could take in other types. And what this type does is basically create an error union. But this error union is specific to my domain, is specific to Redis. So what it does is that here, I didn't do const reply equals, but imagine, because I didn't have much space, but imagine this is const reply equals, and then this command. When you then get the reply, you can switch over it, and it has 3 cases: nil, which is a special case in which Redis, it's null from Redis, it's null from Redis. There's the error case, and in my type, I'm not only having the error case just as a Zig error that doesn't have any payload. In this case here, I'm also carrying, I'm also deserializing from the connection. There's a short string that tells you a little bit more about the error message from Redis, and I'm giving it to you. And that's because I engineered this type. And then there's the OK case that returns your type, whatever it has to be. So in this case, I'm using both. I'm giving you an option. Do you want to inspect errors and like pay the price on your stack frame to store the error case and do something with it? Or are you fine with just the enum from Zig? You can choose. Either way, it's fine. Either way works. And I'm allowing you to use both. And I think it's very beautiful that you can bounce from one another. And the interesting thing is that here, if you try to handle all error cases with a switch case, right? So not just with try, but with a switch case, the switch case will tell you what are all the possible errors. And from this call, you will have to handle also got error reply and got nil reply, because I64 doesn't handle nils, null replies from Redis. And you will have to handle both. While here, if this try becomes a catch, you will have to handle potentially all the networking related errors like broken pipe. But here you will not have, again, I'm clicking, you will not have the error case or the nil case. Another thing that I did in my language here, if instead of I64 you have an optional, so question mark I64, an optional I64, the got nil reply error will disappear too. So it's nice. You can do this stuff, and I think it makes for beautiful APIs. To recap, Zig errors, they're very nice, but they don't have payloads. And it's actually nice that they don't have payloads. You don't want everything to be, every error, you don't want to pay a big price. You don't want your functions to like go at half the speed just because you implemented errors. They have very little overhead, and that's amazing. Panic, it's for runtime. Don't be lazy. Don't abuse Panic. If you're writing a library, please don't leave Panics around. Unreachable, it's for performance, and it's checked for safe modes, which is nice. Write tests that ensure that your unreachable stuff is actually unreachable so that you can discover that. Compile error is super nice because it gives you compile time safety, and it makes for better APIs, because you can have an API that has a usage contract that is a bit more nuanced, but there is no runtime price for it, and there is no jankiness related to it, and that's amazing. Errors and values for when you need payloads, for when you want to do something more nuanced, something that applies nicely to your domain. And that's, I think, is pretty much for my presentation. So if there's any question, let me know. I'll be happy to answer. Otherwise, we can move towards the end. I'll give chat a little bit, and maybe in the meantime, I'll also read the messages that I lost. Let's see. Oof. What slide software are you using? I'm actually using just Google Slides. I'm lazy. But I'm using a website for coloring the code. If you just Google color, like highlight, syntax highlight, Google Slides code, you will find, I think it's like the first result. And yeah, it's nice. You type in your code and then it shows you it colored, and you can copy and paste it inside Google Slides, and it works. Let's see. It was a 40-minute talk. Debugging AWS code errors is hell. Oh yeah. AWS doesn't do a great job in terms of programmer interface. Programmers are not their customers, unfortunately. Yeah, errors are nice. No one bothers to make an enum with possible errors for every function in Rust, so every case has one big error enum. In Zig, it's nice because you can compose them. So yeah, that's a very thing. Well, the author of this comment probably knows it. I'm just mentioning it since I'm reading the comment out loud. Nice. So I think everybody liked it. Oh, let's see. Any message on Discord, maybe? Is this a serious message, or is this an unrelated message from somebody that is not watching? Oh no, it's a comment from Felix. Okay. So since that doesn't seem to be questions, let's move to the end. Let me spoil what the next talk that I'm working on is. Next talk is Advanced Hello World in Zig to become an extreme programmer. So if you want to learn more about how to do Hello World in Zig, watch the presentation. It is, you might think, well, what are you talking about? Hello World? Advanced Hello World? What does it mean? Hello World programs are a bit more complicated than it might seem once you take them seriously. And yeah, there's actually a lot to talk about when it comes to Hello World. So stay tuned. Also, next week, the other speaker is actually was in chat, right? It's Joachim, right? Yeah. So we're gonna have also another interesting talk, which is gonna be about stage 2 and ARM support. So if you're interested in that, also that's another reason that to watch. And honestly, I don't think I have anything else except maybe well, you know, the usual stuff. Share, like, subscribe, slap the bell button. There's the newsletter, follow on Twitter, toss a prime to your Twitcher, whatever. Bye bye.
This is how we